Welcome to First Canada's FTC Sim tutorials. This series is about how to use FTC Sim, a first tech challenge robot simulator created by First Canada. This is getting to be a long series now. We've done a whole bunch of these. Today's episode is about bugs, as you'll see shortly, and debugging, of course, if there are bugs. But if you're new to this and you have not created an account and been able to do anything in FTC Sim, here's how you do it. You go to firstroboticscanada.org/FTC Sim, and there's a little button here that allows you to sign up for a free account, which will then take you to something that looks like this, where there's a challenge that you can do, and there are actually I think about 30 challenges in all. There's a programming screen where you drag and drop blocks, as they're called, into this function, the run op mode function, and then you click on the go button to test your code. And in virtually every one of these, the object of the game or the challenge is to get your robot as close as you can to this flag. So hopefully you are going to enjoy this. Before we get started, a little bit of background, a little bit of computer science background. And today we're going to learn a little bit about Grace Hopper, who, as you can see, was a computer scientist. In actual fact, she was in the military in the United States, and she worked on massive robots, like massive computers, room-sized computers, like the one in the graphic here, that you could actually walk into and change. You had to move wires and unplug things and plug things in to actually change the program. So it's quite a different way to do it than we do it now. But one of the things that Grace is known for, aside from the great things that she did, she's also known for coining the phrase that this program has a bug in it. And that means that a program doesn't run properly. Sometimes we refer to that as having a bug. It just means that we need to go back in and fix it. And back in Grace's day, that originally meant walking inside, opening a door, and walking into the computer and making some changes. And one time when she did that, the program wasn't working, the computer wasn't working properly. She came back out with a big moth, and that was the bug that was in there. And that's a term that's been coined since then to describe it. So here we have a program, and we're going to debug it because, as you're going to see, it doesn't work. Now, that's pretty cool that it can spin like that, but there's a problem with that. We're not getting any closer to the flag. And at certain points we get a little bit closer, but not close enough for it to stop and say, hey, great, you did it. So we're going to stop that. Now, there's a couple of things that we can do. We might know the mistake right away because we've done it a whole bunch of times, and this is the case. But we may not know. So one of the things that you should know is that there are two motors, one on each of the back wheels, and the part that comes out from the motor, the little axle, is goes right into the wheel, and as a result, one of them spins in one way, clockwise, and one of them spins counterclockwise because of the way they're oriented. So what we need to do, and it's a very common thing, which is why they actually have a thing for setting the direction, we can set the direction of one of the motors to go in reverse. So now the left motor is going to spin in the same direction as the right motor. So of course that's done. We're done. So away we go, and we're not quite done. You can see it's still trying to move. It's sliding to the left. I think that's the cha-cha slide, which is quite popular at FRC and FTC competitions. But not so good when we're in FTC Sim and we're trying to make the robot do something. We have another bug. Another bug is that maybe we don't understand what this line of code does or what we need to do to make the motor stop. So essentially what's happening here is that the motor's going, and it's going to say, let the motor go. These two motors run at top speed, which is 1 for 1500 milliseconds, which is a second and a half. But what we need to do as well is we actually need to tell, after that point, after 1.5 seconds, we need the motors to stop. So we actually have to say that. So a lot of times when we're in our real lives, we will say something and it'll have a meaning. It'll actually have two meanings, but the computer and the robots don't get that. They don't get that you're meaning to do two things. They can only do one thing at a time. So for example, if you told someone to open the door, well, they know there's a whole bunch of things. One of them is that you got to get up, get close to the door. You got to reach a hand out. You got to turn the doorknob perhaps, or push a lever down, and then you've got to pull towards you. Or if it's a different kind of door, maybe you just have to stand there and push. Or maybe if it's a door that opens automatically, you need to walk so that you get within a certain distance. Okay, so all of those involve multiple steps, which we can do, and we can do intuitively after a while after we've been taught. But the computer and robots, they need to have very specific instructions. So you have to tell it to go, and you can tell it how long you want it to go for, but when it's finished doing that, it's looking for another command, and that's the command there is to tell it to stop. So there we go. We get close, and it works. Now, sometimes when we're trying to debug, we'll actually put code in there to sort of help us out. In a longer program, we don't know what a value meant and why it didn't change. So that's one of the reasons that there's telemetry in here. And so telemetry might be that you want to put down the motor speed, and then you want to have a value. Typically, you'd put down some calculation or a variable, and that will then tell us. It'll show a little box up there. I'll just show you. It won't have much in there, and right there it says, oh, here's our telemetry. And it really doesn't say anything because it's just repeating what we've got in there. But sometimes we use that to make it clear what is taking place. And we'll find out, oh, this value wasn't in there. And it should have been. So the last one we want to mention is that one of the things that sometimes happens is that, I'm going to take that one out of there, is that we don't put things in the correct order. So there's a sequence that has to follow. In this case, it's top down. It's going to do every command in order from top to bottom. So let's see what happens when we do this one. It doesn't really do anything because the part that set the motor in reverse occurs after the motors go. So that means that we have a small bug in there. So those kind of errors, the errors that we're looking at, the bugs, they're called logic errors. Logically, it would make sense to turn the motor into reverse before we actually started to give the motor power so it can move. So hopefully you learned something about Admiral Grace Hopper, as she was when she left the military, and bugs and how to do some debugging in FTC Sim. Hope you enjoyed that. Hope you're staying safe in these COVID times, and we'll see you back again next time for FTC Sim tutorials from First Robotics Canada.